Welcome back to our online tutorial, and today we are going to solve this problem from the topic forces and Newton laws of motion. And the question read, two forces F1 and F2, so here is F1 and F2, are pulling a mass of 2000 kilograms, so this is the mass of 2000 kilograms along the x-axis as shown. If F1 and F2 is equal to 600 newtons, so it means force 1 and force 2 have the same magnitude, which is 600 newton, and theta 1, the angle that F1 makes with the ground is 30 degrees. This is 30 degrees along the x-axis, and theta 2 is minus 45 degrees, so here it is minus 45 degrees. So it means that this angle or this force is acting below the x-axis, that is why it is minus 45. So the question says find the magnitude and direction of the net resultant force on the object and the initial acceleration of the object starting from rest. So the first thing that we need to do, as usual, we need to write our data. So this is our data. Mass is equal to 2000 kilogram. Force 1 is equal to, force 2 is equal to 600 newton. Theta 1 is equal to 30 degrees, and theta 2 is equal to minus 45 degrees. So now for us to proceed, then I'll divide this part so that we can have space. For us now to proceed, the first thing that we need to do is to write these forces in their components. Because of the angle each force makes, it means that it is in the x component and y component. So we can start by saying force 1, F1 in the x component will be the magnitude of force 1, which is 600 newton cos 30, and that's gonna give us quickly, or 600 cos 30, and that's gonna give us 519 newton. It's gonna give us 519 newton. And force 1 in the y component is going to be the magnitude of force 1, which is 600 newton, but this time round it is sin 30, which is going to give us 600 sin 30, which is going to give us 300 newton. So we have 300 newton. The same we're going to do for F2, and we want to know F2 in its x component. That is going to be the magnitude of force 2, which is 600 newton cos minus 45, and that's going to be 600 cos minus 45, and that is 424. So that gives us 424 newton. And in the y component we have F2, y component is going to be 600 newton sin minus 45, and that's going to give us, so we just replace by sin, so just say 600 sin minus 45, and that's give us minus 425 minus 424 newton. Okay, so from here you can see we have F1 in the x component, F2 in the x component. So we can find the net force in each component. So we can say Fnet x, meaning the sum of forces in the x component will be force 1 in the x component plus force 2 in the x component, and that's going to be 519 newton plus 424, and that's going to give us plus 519 newton That's going to give us 943. So 943 Newton. And F in the F net in the Y component is going to be F1 Y plus F2 Y, which is going to give us F1 is 300 Newton plus minus 424, and that's going to give us 300 Newton plus minus 424, and that's give us minus 124. So we have minus 124 Newton. So these are the components of F forces in the X component and Y component. So the question reads, find the magnitude and direction of the net resultant force on the object. So it means that our magnitude, so the first we're going to calculate the magnitude, and you know magnitude of the force net magnitude will be the square root of F in the X F net squared plus F net Y squared, everything under that, and that will give us, if you write everything square root, that will be X with 4943 squared plus Fy to be minus 124 minus 124 squared, and that's gonna give us 951. So this is gonna give us 951 Newton. So this is the magnitude of the resultant net force. So we can look for the direction. Remember, direction is the theta. So direction will be theta is equal to tan inverse of Y component Fy over Fx net. So we're just gonna say net here, which is tan inverse of Y is minus 124 over X is 943, and that's gonna give us a value of, let me just write it here, minus 124 over 943. So this is the theta is equal to tan inverse, and this is gonna give us, so we have tan inverse of minus 124 over 943, and that's give us an angle of minus 7.49 degrees. So this is the direction. So this is how we attempt the first question. The first thing is to write the components of each force, F1 in the X component and F2 in the F1 in the Y component, and F2 in the X component, and F3 in the F2 in the Y component. And then we look at the sum or the net force in the X component, which is the F1 plus F2, which give us 943. And we also look at the net force in the Y component, which is the sum of all the Y forces, F1Y plus F2Y, which give us minus this. And we look at F net, the magnitude. This is the magnitude. So magnitude will be the square root of F net X squared plus F net Y squared. And if we do that, we get 951. And then we can proceed and find the direction. The direction is the tan inverse of y over x. So that's the first part that we do. The second part says the initial acceleration of the object starting from rest. So for us to get the initial acceleration, remember this occurs in x, so we can look in both direction x and y, or in each component. So from the second law of Newton's laws of motion, we say force is ma. Okay, force is ma. That force is mass times acceleration, and therefore acceleration is equal to force divided by mass. So if we look at the acceleration in the x component, then it's going to be the magnitude of force in the x component net divided by mass, and that's gonna be, we found in the x component is 943 Newton divided by mass, which is 2000 kilogram, and that's gonna give us an acceleration of 943 divided by 2000, and that's gonna give us 0.4715. Because it's acceleration, we say then it is meters per second squared. And acceleration in the y component then is going to be force or net force in the y component, net force in the y component over mass, and that's going to give us, in the y component we found to be minus 124 Newton over 2000 kilogram, and that's gonna give us a value of minus 124 divided by 2000, that's gonna give us minus 0.62, gonna give us minus 0.062 meters per second squared. So this is how we calculate the initial acceleration. We have to calculate the initial acceleration based on its components. And from here, you can be told to determine the magnitude and direction of the acceleration. And if you want to find the magnitude of the acceleration, then you can, because of the space, if you want to find the magnitude of the acceleration, you will just follow the same procedure like we did for the magnitude of the force. So magnitude of acceleration will be the square root of acceleration in the x component, plus acceleration in the y component, and that's gonna be, in the x component it is 0.4715 squared plus minus 0.062 squared, everything under the square root, and that's gonna give us a value of, so we have answer squared plus 0.4715 squared, and that's gonna give us a value of 0.47. It's gonna give us a value of 0.476 meters per second squared. So that is the magnitude of the acceleration, in case you are asked to find the magnitude of the acceleration. And if you are told to find the direction of the acceleration, then you're gonna say then the So this is how you can find the magnitude of the resultant acceleration if you are asked. But remember, in our question we are not told to calculate the magnitude of the resultant acceleration. We are just told determine the initial acceleration of the object starting from rest. So yeah, you can still proceed and find the magnitude of the resultant acceleration, and that is 0.476, and from there you can even calculate the direction of the resultant, direction of the acceleration, which is going to be tan inverse of ay over ax, which is going to be this one, this value here, which is our y, divided by this one, and you're gonna get into degrees. A summary of this: for you to find the initial acceleration of the object starting from rest, you need to take into consideration that acceleration is equal to force over mass according to Newton's second law of motion. And because we have acceleration in the y component and acceleration in the x component, then you need to find the acceleration in x component and y component based on the magnitude of the force in the x and y components, and that's this one for y component and x component. And if you want to find the resultant acceleration, then you need to take into consideration that it is the square root of acceleration in the x component squared plus acceleration in the y component squared, and that one will give you 0.476 meters per second squared. And if it happens that you need to go further and determine the direction of the resultant acceleration, you are going to say it is the tan inverse of ay over ax. So that's the tutorial for this one, and I hope you followed to help you for preparing for your test or your exam. Thank you so much. Hey, remember to subscribe, like the video, share with your friends so that we can dissipate this knowledge. Thank you.